end of the talk. Good luck, Andrei.
Thank you, Irina. So, hello, everyone. Ladies and gentlemen, my name is Andrei Epure, and I first have to share my screen. Very important. So, my name is Andrei Epure. I'm a software developer in the languages team at Sonar. We develop the code analyzers that are used in all our products. I'm going to present today what is dependency confusion and how to cure it applied to the NuGet ecosystem. So before I start, to make a disclaimer, I like Sonar, I work at Sonar and I like it. This is why I'm using this template to promote our brand. And at the same time, this is my personal talk. So it's not a Sonar talk. I have prepared it in my own time. And that being said, we can move on. So my opinions are my own. Always got the disclaimer. The goals of this presentation are that by the end of the session, you will know what a dependency confusion attack is. You will be able to identify vulnerable NuGet configurations, vulnerable to dependency confusion, and you will be able to make the necessary changes to protect your projects as a NuGet consumer and to protect your users as a NuGet publisher. So I have a warm-up, and for that I would like to ask people to open their cameras, just if you can, on the people on Zoom. So I have Stefan, and if you want, because I'm gonna ask people to raise their hands, but that's fine as well if that's not possible. So I have some questions. So who in this room knows what a dependency confusion supply chain attack is? Okay, that's great. Okay, cool. I hope that this talk will be useful. Who in this room uses NuGet? Yes, that's great. And who changed the NuGet.config file? Awesome, cool. And who uses both public, the NuGet.org, and the private package feed or source? Awesome, good. And who uses package source mapping? Okay, so this is a good talk for that. That's good. If you, so Stefan, if you would have raised the hand, I should have stopped the presentation, but it's good. So I can continue now. So to share before the moving forward, I want to share the why behind this presentation. So what motivated me and why I believe it is important for me to talk about dependency confusion. And I hope that sharing this why will help you stay focused until the end and will, let's say, make you aware of why this is important. So first of all, dependency confusion, also known as substitution attack, is a supply chain attack. Supply chain attacks are rare. And when they happen, their impact can be catastrophic. So the why behind this is I want to prevent catastrophic impacts in the .NET ecosystem and in the .NET community. So by raising awareness in the community, how to protect ourselves. So brief introduction. What is supply chain, software supply chain? It's, well, before the software supply chain, it's traditionally a supply chain is the sequence of processes involved in the production and distribution of a commodity. So it's basically everything that is required to produce and distribute a commodity. And what is the software supply chain? First of all, is the source code and the writing of the source code. Then the libraries which are used, libraries or dependencies, which are used by the source code, which can be closed or open source, can be public or private. Dependency management systems, and then many more build tools, static resources, certificates, images, artifact repositories, continuous integration, continuous deployment systems, processes themselves like software engineering processes, people, everything is inside the software supply chain, and the vulnerability can happen at any of these levels. And to convince you that supply chain attacks impact can be catastrophic, I will give an example, a recent example of such an attack. So let's take the SolarWinds supply chain attack from 2020. SolarWinds is an American software vendor which has a product called Orion. It is an IT monitoring system. And in 2020, it was being used by more than 30,000 public and private organizations. So it's quite a big usage. And how the breach worked. So attackers breached the internal software supply chain of SolarWinds in late 2019. They got access to it. They injected malware into the Orion product without the company knowing. Fun fact, they did this by hijacking msbuild.exe. So the msbuild process, they hijacked the process on the build machine. And this is how they managed to inject the malware into Orion. And SolarWinds started to send updates, software updates, you know, always keep up to date to get all those security patches. Well, in this case, the software updates came up with malware, and they ended up being distributed to 18,000 customers. And multiple US government agencies confirmed that they were compromised. The number that I found was 9, including the Department of State of the United States of America. So this was a software supply chain attack. It took 14, so that is 14 months to discover the security breach since the initial breach until discovering the malware. And it wasn't discovered by SolarWinds, it was discovered by a customer, which was a security company. And they realized, okay, something weird is happening. And they told SolarWinds in December 2020, and then it became public. And this is why I said it can be catastrophic. So not only the malware got to 18,000 companies, so if that's not enough, this is how the stock price of SolarWinds dropped when this became public in December. So supply chain attacks are rare, are very difficult to instrument. However, when they happen, their impact can be catastrophic. Again, a software supply chain attack can happen at multiple levels. So for SolarWinds, it happened at the build server level, and the build server got infected, and from there it all started. Today, I'm gonna talk about dependency confusion. It's a different type of attack, so not like the SolarWinds one. This type of supply chain attack operates at the level of the dependency management system through libraries. And just to a note about the notation that I'm going to use in my slides, when you see this Ninja Cat hacker, you know that I'm talking about malicious activity. So the Ninja Cat hacker is the hacker. I want to brush up a little bit the NuGet vocabulary before I go into the presentation. At a simplified view, the .NET Dev platform consists of languages and runtime and libraries. And NuGet is the system to manage libraries in the .NET ecosystem. So I imagine everybody knows this. And libraries are inside the NuGet package or dependency. They contain descriptive metadata, including the version, and eventually they contain target files that can execute arbitrary code on build machines. Eventually, it's possible. I'll show you a demo later on. So, and regarding NuGet versions, we can have fixed versions like 1.2.3. We can have a range inside the package references inside the CS proj file or VB proj file. We can have ranges. So this means that it can be any version up to 1, 2, 3 included. And then we can have floating. So floating version means a wildcard version. So in this case, it's 1.2 point star means any bug fix release of the 1.2 version. A NuGet package source is where packages are stored and can be retrieved from. So source or feed, they can be used interchangeably. NuGet source or NuGet feed, it's the same thing. They can be on a NuGet server, which can be public or private. NuGet.org is a NuGet server, can stay on a network location or on a local folder. And then NuGet package resolution. How does NuGet find the packages that your project needs? So you mentioned them in your project file, and then what it happens is that the NuGet executable will send queries to all configured package sources, and then the fastest response from all sources wins, is selected. So why is the rationale behind this? Think of Microsoft, big company. It has employees around the world, so there are multiple repositories in multiple data centers, and it makes sense in terms of geolocation to try to get the package from all. We're going to see later on what this means for dependency confusion. And then with a unique package source configuration, say that these packages are on NuGet.org. If my project wants package full version 5.3.star and package bar 1.star, what will NuGet return in this case? So you can open your mic and say. Anybody? Stefan? Chat. I can unmute. So 531, that's good. Indeed, so it's 531 and 140. So, and I'm also like this, I am introducing let's say the notation of that I'm gonna use later on. So this is my code, this is the NuGet executable, and then on the right hand side, it's the packages and the communication. So again, my code says give me 5.3 star, and if I have on repository 1 a 530, on a repository 2 531, what will NuGet, which package will NuGet give?
I guess it's now first wins, isn't it?
No, so not really, because here it will look for the best match, and
okay.
in this case it's gonna be 531 from repository 2, because there is this floating version, and it first looks for the best match. So if in case multiple repositories have the best match, then it will query all, and then it will get the first result. So here it will return the best match from all sources. And then here, this is the question. So if it's a fixed version and there are 2 repositories configured, in this case, what will happen is non-deterministic result. So indeed, it's the fastest network call. So that's non-deterministic. That's about it, let's say, for the introduction. So I am now going to explain how the attack works. So I will need to become like a hacker, because now I was dressed like a nice dev, and I need to become like a hacker when I explain this. Just a second. Okay. Wait a second. Okay, almost. I still have my dev t-shirt inside, so I still have a grain of mercy. Now I am merciless, and I am also very hot. So I'm now a hacker. And the first attack I'll mention is called typo squatting. So this has been mainly used in NPM, so in the Java TypeScript world, and in Python, PyPy, dependency management systems. There's many articles online about typo squatting on NPM. However, it's also possible that a NuGet developer enters a typo and an attacker takes advantage. So in this case, if on the public repository we have google.protobuf, we know we have it, and dev writes a single O, so it writes Goggle protobuf. In this case, NuGet restore will fail because it will not find the package. However, if the NinjaCat hacker, I as an attacker, NinjaCat come publish a malicious package, I can even use the Google protobuf binaries because they're publicly available. I put them in a NuGet package. I name the NuGet package Google protobuf. Why not? Sounds like a good name. And in this case, the malicious package will be returned. So this is typo squatting. So it's also a dependency confusion attack because the resolved dependency is not really what you think it should be. I won't talk more about typo squatting in this presentation, but I wanted to introduce the notion. Now, another dependency confusion attack is public version of private package. So my code has configured a fixed version for a private company package, which is internally developed. It's in the private company repository, which is super safe. And somehow I, as a hacker, find out the name of the package. I can do that from open source projects which reference the private package library, or from some screenshots from a Twitter account, or from social engineering, going to some party with the devs, asking what packages they use. And then I, as a hacker, publish the company.foo package on NuGet.org. So what will happen in this case? It's non-deterministic result. So it will depend on the network speed, and that's not the best thing in terms of security. So it's at the mercy of chance. And another type of attack, let's say that we want the latest bug fix release from the company library, from company.foo. It makes sense, I don't want to increment all the time bug fix releases because of another team publishing a lot of bug fix releases on company.foo. So the developer will use the floating version. And then I, as an attacker, I just publish company.foo 99999. It will always be the biggest version. So in this case, you can be sure to get the malicious package. So it's not going to be a non-deterministic result. It's going to be very deterministic. Okay, so let's see a demo of the attack in practice. I'm just gonna clear, and then just a second. I wanna first empty my local cache. Sorry, I'm gonna become a lesser hacker because I cannot see. So I have my corporate app solution. It's a corporate private app, so of course it is private. It uses the corporate private library and newtons of JSON. So this is the most downloaded package from NuGet.org. And you can see this is the corporate class. So if I go inside, I see that Visual Studio resolved the package, and it's in my NuGet packages corporate private library. Sure, it's all good. And my NuGet config is basically NuGet.org and the corporate NuGet source, which is a folder for this particular presentation. So and you can see also, so my NuGet source is having two packages: is the corporate private library 100 and the corporate private library 101. So a bug fix. So this is all it contains. And then basically I built all good. And then someone calls me, hey, we published the bug fix release. You need to use it. Before that, I just want to show you what happens if I run .NET restore. Just a second. I need to be in my corporate app. Okay. So in my .NET restore, I should have at the top, but sorry, not detailed. That's too much. Normal. Okay, so just a second. Okay, here it says the feeds. I want to show you that it gets it from the local feed. So I'm gonna clear all again, and I'm gonna run NuGet restore. So you see here, it says installed corporate private library version 100 from my corporate NuGet source. So this is what I wanted to show you. It restores it from my corporate NuGet source. And then, as I said, I get a call from my manager, hey, update to a bug fix release. And I say, hey, I'm smarter than that. I know how NuGet works. I'm gonna use a floating version. And I'm gonna now run .NET build, actually, which will do a restore. So the build does a restore. And all good. And you see this calculator appeared. I didn't open it. The build somehow opened it. So this is weird. Why would the build open a calculator? It seems like it's running arbitrary code. And also, I see a warning. So arbitrary code has been executed. Well, that's a very kind hacker, but anyway, it gave a warning. And here, I said, okay, it has normal verbosity. I apologize for even normal verbosity is quite verbose in terms of build, but in terms of restoring, you can see here that it's not getting the package from the local NuGet source. So from the it's actually getting it from NuGet.org, corporate private library. So let's see. I'm very confused. I want to go first to NuGet.org. So I'm gonna search for the package. So let's search for my corporate private library, because this really makes no sense. Probably a colleague published it and it makes no sense. And I don't find it. So how did this get downloaded? So I go back to my corporate app. I go back to my program. And actually, here, if I build, okay, the calculator opened again, and I see, okay, I see the warning, and if I click on the warning, I can actually see the target file that gets executed. So it's the target file in the NuGet cache. I now see that it's version 109999. So I didn't want that. I wanted bug fix 0.1. It's version 9999. and it's executing calc.exe and warning text. So here you can put whatever you want in a target, whatever you want, and whatever MS build has the right to, like whatever the .NET tool has the right to execute, you can execute in a NuGet target. And then I just want to show you that, okay, I cannot find the package, but if I write the link directly, I can find it. So it's here. It's, of course, published by an evil hacker. The evil hacker has no packages here, but if you know the link, it shows the owner has unlisted this package. The thing is, so unlisted packages can be, I mean, sure, it's just obscuring. It's not that difficult to construct this URL if you know the name of the package, but still it adds some obscurity, so it's a bit more difficult to diagnose. That was my first demo. So you just saw this in practice. Okay, so you might say this is too simple. This wouldn't happen in real life. The fact is that I'm now just gonna become less of a hacker because I'm too hot. The reality is that in February 2021, the security researcher Alex Birsan, who is actually from Iași, so that's a nice coincidence, he published his results about this novel supply chain attack called dependency confusion. He actually hacked into 35 large companies, and he was rewarded the highest possible bug bounty, but by each of the top of organizations. So he got $40K from Microsoft, $30,000 from Apple, Shopify, PayPal, other thousands of dollars from bug bounties from Tesla, Uber, Netflix, and other big companies, mainly using NPM and Ruby gems. It is true. However, as I just demonstrated, NuGet is vulnerable to this as well. So let's see how to identify vulnerable NuGet configurations. So in a nutshell, the default NuGet configuration is vulnerable to dependency confusion just because it does not guard against typo squatting. So there is no guard against typo squatting. If you do a typo and an attacker publishes that package with a typo on NuGet.org, you'll get the malicious package. So I will show later on how to defend against typo squatting in the NuGet configuration. Second, if the configuration specifies a hybrid config, so you see at line 4 and 5, there is one package source, and line 6, 7, another package source, NuGet.org. And what I showed you in my demo, this is vulnerable to the public version of private package attack. So again, this is a vulnerable configuration as well. How to protect? So let's talk about how to cure, how to find a cure. As a NuGet consumer, so for the projects that we maintain, the first simple step is, well, this doesn't really protect against dependency confusion. However, it ensures deterministic behavior of a NuGet because NuGet inherits behavior from the default config and from the folder structure. So if you have in the parent folders, you have other NuGet configs, it will be inherited. So the idea is to always use clear, because you cannot be sure of what happens on the CI systems. You cannot be sure of what happens on environments that you don't fully control. So always clear, avoid unexpected behavior, make sure you have deterministic behavior and unexpected surprises. So it's a very easy step to do in each NuGet section. And then second, use package source mapping. So this was a feature introduced in NuGet 6. So in November 2021, roughly 9 months after Alex Birsan made his dependency confusion results public. So package source mapping is the solution for hybrid source configuration. What this means is that you actually declare which packages should be downloaded from which source. It's simple. So you do a mapping for all your private packages, you do a mapping to your private sources, and for all your public dependencies, you do a mapping to NuGet.org, and it's good. This problem is solved. So let's see the demo, how this works in practice. Okay, so first, clearing my NuGet cache so that I don't have demo effects. Checking out. Okay. Just a second. Okay, and now checking out. Good. I am good. So I have again my corporate app and my CS project. I have my corporate library. You see now I kept the floating version of the library, and this was the vulnerability. And in NuGet.config, you see I declare here, it's the same package sources. I added the clear at line 4. I added the clear statement, and then public NuGet and private. And package source mapping, again, clear first, then for public NuGet, say I want Newtonsoft JSON, and from private source, say I want all the packages that are corporate private star. So you can use wildcards in your package source mapping to make them more efficient. And let's see if I do a build. Okay, I have a build, and please remember that in my CS proj, I have a floating version. Okay, so this should be vulnerable. However, you can see here that okay, probably I haven't cleaned. Okay, just a second. Demo effect. So I am cleaning, I am rebuilding, and if I look in program.cs and I go inside the corporate class, you can see that I am using the version 101. So it's not using the one from NuGet.org. So it's using the one from the local feed. Okay, so I will just a second. I see a question. Can you configure NuGet to prefer private sources instead of public? It's a very good question. So this is exactly what package source mapping does. Please note that NuGet itself doesn't know what a public source is and what a private source is. So you can specify, you can map packages to a particular source, but NuGet doesn't know, hey, this is private or this is a public source. So you need to do your manual configuration for this. Cool. So that was the demo. Another example that I can show you, which is a bit more, it's a, let's say, bigger example than this with 2 packages is on NuGet gallery itself, which has a little bit more packages. So this is how, let's say, okay, so zooming in, this is how let's say real life project looks. So again, it's NuGet is the public one, and then NuGet build is their packages.dev.azure, so private for Microsoft. And you can see NuGet, public NuGet is has all these. You see here autofuck.star. It's using stars. It's using NuGet.star, runtime.star, and then here it's using some internal build packages. And the most when it looks for the most specific packages. So here you have NuGet.star, and here you have NuGet.jobs.star. So this will take precedence over NuGet.star because it's more specific. So that's another mention. Coming back to the presentation. Come on. No, doesn't want to full screen. Okay, full screen again. Good. So I'm now moving on from the following features are not from NuGet 6. So to use package source mapping, you need to use NuGet 6. With trusted signers, the idea is that if the owner of an open source package that you use changes, you should know. Why? Well, you need to trust the new owner. So if an open source package just changes owners, you need to be aware of what happened there, because when you started using the package, you probably did a little bit of research whether you can trust the owner, and then you need this chain of trust to be verified. So with trusted signers, you say, just a second. Basically, the idea is why you need to trust the owner, because a malicious anonymous user can become a maintainer of an open source project. It can act as a contributor, and then like 6 months after become a maintainer and publish malicious updates. So, and I can give an example. OpenCover, it's a code coverage tool. It's not a bad example. It's just an example that the maintainer archived the repository. However, another possibility would have been to say, hey, I don't want to maintain it anymore. Does someone from the community wants to take it? And then someone from user X would said, yeah, I want to take it. So and OpenCover is really used by many pipes. In this case, he just archived the repository, so it's done. And also, it's very important to ask maintainers to sign their packages, because this is how you can be sure of the integrity of the package if it's signed. So to enforce this, there are a few sections that you can use inside NuGet config file. So one is to specify the repository certificate. This is not that useful for NuGet.org, because basically all the packages from NuGet.org are signed with the NuGet.org certificate, including my evil package. So my evil corporate private library 9999. So it has the signature. Then again, you can specify accepted package owners. So there is an owners section, and you can specify the owners of the packages that you accept. And if the owner shall change at a future version, NuGet restore will fail, and you can inspect. And then you can specify owner certificates. And just to show you Sonar scanner for .NET. So this is basically the tool that orchestrates the analysis for .NET projects for SonarQube and Sonar Cloud. And this is how it looks like. We have a single package source, which is a proxy for NuGet.org to have some control over it. And then you see here, we say that we require signature validation. And in trusted signers, we have a trusted repository. It's NuGet.org. Here it's 2 fingerprints because some packages were signed with certificate valid, that got expired, and we still use the old versions. So NuGet.org doesn't re-sign the packages. They just stay with the old certificate. So if you use packages from 2018, they will have the old certificate. And starting from 2021, the certificate changed. Here we keep a list to know, like, because the names are a bit cryptic, like KZU, who is this? But we keep a list as comments to know what we have here. And basically, these are the only owners that we trust. And if something will change, we will have a build break. And this includes owners of transitive dependencies, as far as I remember. And here, the only package that actually has its own, that is signed by the author, is Newtonsoft. So Newtonsoft is signed by the author, and we enforce the certificate there. The others are not signed, so especially older packages are not signed. So this is a practical example of how our NuGet config looks like, even if we have only one. Even if we have only one feed, so it's not a hybrid configuration. This is how we guard against typo squatting, for example, because in case I will mess up one of the package names from Microsoft, for example, because there can be, if I just add another package from Microsoft, I won't have to update this. It's still Microsoft the owner. But if I mess up the name, and a malicious packages with the typo inside, it will fail because the owner is not in this list. Okay, so just going back into presentation mode, and I hope that, come on, why it's okay. Okay, so I gave the example of Sonar Scanner for .NET. And okay, I went into presentation mode just to go for the next demo. Sorry for that. Okay, so again, clear the NuGet cache. And then I will check out another tag on my repository. And I go back to my Visual Studio and my corporate app. So I can show here, you see I added the trusted signers for both for this repository and for the author. And you see, I removed the package source mapping just to show that this is also a guard against dependency confusion, even if you do not use NuGet 6. Because here from public.NuGet, I say that, okay, the only owners from public NuGet that I trust is James and Kay. And here you can see again, I have 10 star. So when I do a build, well, I get a message, package corporate private library 109999 from source is signed, but not by a trusted signer. So yeah, this is a good enough message to guard against surprises and dependency confusion, even if you don't use NuGet 6 for whatever reason. So you cannot use package source mapping. Use trusted owners, and this will be a very good safety net, because yeah, so here I realize that okay, something is weird. So in this case I will just specify the fixed version, or I'll think about package source mapping, but at least this will fail before the package gets downloaded. So this will fail just at NuGet restore, and the build won't execute, and the calculator app won't. Oh, good. I'm in full screen. So the calculator app won't open. Moving on. One of the recommendations from Microsoft is to use fixed versions. Like this, you limit the surface area of a possible attack. I personally believe that using a mix of everything is best, because you really use all the safety nets that you can. So by using fixed versions, you have full knowledge and control over the supply chain. And then to be fully aware of what's inside the dependency graph, you should use packages log.json, because there can be a lot of transitive dependencies. Each package can have a lot of transitive dependencies. And if you want to be aware of everything that goes inside your product, you should use packages.log.json. You can, like this, you can enforce the build to fail if some version changes without you expecting it, if some versions during the dependency graph changes, especially on transitive dependencies. And also this will improve the performance, because the dependency graph doesn't need to be recomputed. It can be a little bit of a pain as well to maintain, depending on how you use it. And then transitive dependencies, this is from Microsoft Docs. So you use the direct dependencies here, A, B, C, D, E, and then each of these can have transitive dependencies of different layers of nesting. This is just to make it, let's say, obvious of how complex the system is. Okay, so another demo, and this will be my last demo for today. Again, clear the cache. Check out demo 4, open my corporate app. So I've added, again, I have 2 package sources. I want to demo each of the features that I present in isolation, so that it's easier to understand what they do in isolation. So I have restore packages with lock file set to true, and restore locked mode set to true. This means that it will fail if something changes. And another very important thing is that this is the file that gets created. So the packages.lock.json file, I checked it in for the versions that I have. So it's 101, and in my, yeah, I have 101 here, you see, and then I have 101 here as well. So it is a it mentions direct or transitive dependency, and then in my CS proj, if I change this to star, so that I get all the bug fix versions, and I do a build, it will failed. So it says that the package's log file is inconsistent with the project dependencies. So restore cannot be run in locked mode. And then if I change locked mode to false, so this, or just remove it, you see, if I run this, my calculator got opened again and arbitrary code has been executed again. And if I do a git diff, you can see that, okay, first these are the changes that I did. I added the start and removed the restore lock mode. And then here you can see it resolved the 10999. Basically, it brings awareness of what changed. If you don't have restore lock mode set to true, it will update the log file, and it will still download. So this is to be aware of your transitive dependencies, and to be aware when something changes. Again, as a NuGet publisher, how can you protect your consumers, the consumers of your NuGet packages? Please reserve your prefix. So also for your private packages, this means that if you reserve the prefix, in the case of our app, it would be, you can reserve corporate.private or corporate. Basically, it's just the substring. This is what the prefix is, a substring of the package, or just the full name. That's fine as well. And what this means is that nobody else will be able to publish packages with the prefix. So this can prevent typo squatting. Obviously, if there are typos in the prefix itself, then it's a different prefix. But if someone wants to publish packages with Sonar source dot, they cannot, because we reserve the prefix. And then please reserve the prefixes for your enterprise packages. Like this, you really prevent substitution attacks. You go to the root of the problem. You just prevent hackers of using those names. This means nothing for it's nothing public. It's just Microsoft that reserves the prefixes, and then if someone wants to publish with those names, they won't be able to, because the prefix is reserved. But that's and it's very easy to do. It's just an email. It's an email sending to Microsoft. They ask for an evaluation. They ask like 4 or 5 questions. And I sent them an email a year ago to reserve the prefixes that we use, and also that we don't use, but we don't want others to use. For example, Sonar source, we don't use this prefix, but we don't want somebody to impersonate packages from Sonar source. So we sent to the email account at Microsoft. I think you can find the email anyway on the Microsoft Docs. There's really comprehensive documentation on how to reserve the prefix. So I just asked them. I said why. I put the self-evaluation. I'm skipping it for this presentation. And then they replied within a few business days, okay, reserved prefix. I'm just hiding the name of the person because the person didn't agree to be part of this presentation. So it was really easy. And then what does this mean in practice? How does this look like? This is our analyzer, and it will have this prefix reserved tag. So this is a token of trust from NuGet.org. Hey, the owner reserved this prefix. So this means that Microsoft did at least some sanity checks on the owner. The fact that they are, it's a good they have good reasons to reserve the prefix. No, I expect that if someone from nowhere tries to reserve the prefix for your company with the name of your company, they shouldn't. And also when you look up packages here, they look like okay, how do they look? Because this means that it's installed. This green thing doesn't mean it's trustworthy, but here they have this notation basically. So this means that you see these are with reserved prefixes, and this cake.sonar is from someone else. It doesn't have a reserved prefix. So this is a token of trust. Moving on, sorry. Okay, so reserve prefix, sign packages. This allows the author certificate validation. If you don't sign the packages, this won't be possible. I showed for Newtonsoft JSON that in the NuGet config, I was asking for a signed. I was checking the certificate of the package, and then this allows your consumers to verify. And here on Sonar Analyzer.C#, I can show you in NuGet Package Explorer. So here is how it looks like. It has the publisher, and the publisher has a signature. So it has a valid certificate, and then the repository signature, which everybody has. It mentions the owners, and the signature is valid. So it's quite easy, and it means that your users can trust the package. And I can also show the signature. So here on my corporate private library 999, I can download the package, I can open it, and you can see here it has the repository signature as well. So owners evil hacker. So the repository signature itself is not that useful. Okay. Also, having deterministic builds allows mapping the package to a specific commit. This increases the transparency and allows consumers, for example, to audit open source code to know the commit of the package that went there. I can show for Newtonsoft, they have this. We don't. This doesn't really prevent dependency confusion. This is just another step to increase the trust or to the transparency. So here it has the commit ID, and repository, it has the commit ID, and the package is clearly mapped to a commit hash, and it can be deterministically recreated. So this is why I'm mentioning this, even if it's not strictly related. So this allows mapping of a package to a specific commit, increases transparency, and allows consumers to audit open source code. So this is mainly what I wanted to present. I'm now gonna share some conclusions. The biggest one is be aware of what you're using. This is a quote from Microsoft documentation. Being able to leverage the work of thousands of open source developers and library authors means that thousands of strangers can effectively contribute directly to your production code. So it's, in a way, it's obvious, and in a different way, it's not that obvious that, hey, look, I encourage you to, on your projects that you work on, to enable even locally the packages.log.json just to see all the transitive dependencies that you are using in your projects. This might be a surprise or not to see the complexity, and to even adding and I really encourage you to add trusted signers, and this will force you to go through all the owners of all the open source projects that you are using and ask, okay, can I trust this account? And then a software supply chain attack is in and of itself rarely the end goal. So it's the beginning of an opportunity for an attacker to insert malware or provide a backward for future access. So this is what happened with SolarWinds. The supply chain attack itself stayed hidden. That wasn't the purpose. And they won't add warnings in the build logs about executing arbitrary code. So, and another thing, this is a visual representation again from the Microsoft documentation, the full life cycle of a vulnerability. So most of the time it stays undetected. This is in general, vulnerabilities in general, not only supply chain vulnerabilities, but vulnerabilities in general. Usually since they get introduced, they stay undetected, and then they get fixed, then users are alerted. But this is very important to be aware of, the fact that having a vulnerable NuGet.config file can have serious implications. So these are some links. I will share them at the end. It's all public documentation, so nothing. It's all public documentation from Microsoft on the NuGet documentation, and this is a white paper they published after Alex Birsan released his findings, and it's nice that it has details also not only for NuGet but also for most major technology stacks, how to advise on how to protect against dependency confusion. And yeah, manage package trust boundaries. This is what I mentioned with trusted signers, locking dependencies. This is about packages.lock config. And then the package ID prefix reservation, it's very good, extensive documentation on how to do this and what they ask as a self-evaluation. So another thing is, okay, in my opinion, it would be nice to ask the maintainers of the third-party packages that we use to reserve the prefix and to sign their packages. I think this is important. And also I encourage all of you to harden the NuGet configurations of your projects. So this is the original article from Alex Birsan on how I hacked into Apple, Microsoft, and dozens of other companies. Last but not least, in Sonar, we are hiring both remote and on-site. I'm always looking to have new colleagues. We make the software world a cleaner and safer place at Sonar, and we have positions for .NET Ecosystem Product Manager. You'll find it as Language Ecosystem Product Manager on the site, but you can mention it's for, you prefer for .NET, and then .NET developers. And last but not least, please give feedback. Feedback is a gift. I will share this form with you at the end of the presentation, and inside the form you find all the links. Inside the description of the form you find all the links, including to the repository that I used for the demo, so you can play around with target files, you can play around with dependency confusion if you want to use that to demo inside your team, company. Feel free. So when you go to that feedback form, don't forget also to give me feedback. And I will share it on Meetup, on the Meetup group. And I think I can ask Irina and Bogdan to put it maybe on YouTube as well, or I can put it as a comment, or yeah. And that's it. I'm open for questions if you have.
If you have the link at hand, I can paste it on the
Yeah.
YouTube
Yeah.
because we're a bit.
Yes, of course. I can put it in the chat, by the way. So this is it. I hope it works.
Yep.
Yeah, basically you see that I have all the links here, and then the link also to the blog post about the supply chain attack I mentioned, SolarWinds, and here is the GitHub link to the repository, and there's not many questions. It's just rating and giving me hints or how I can improve. And this is the dependency confusion demo with the corporate library, corporate app, corporate NuGet source, and evil library. So that's it. I don't know if you have questions, remarks. I'm more than happy to talk.
So on YouTube, there is one question that you might have answered, but I'm gonna read it anyways.
Yeah.
Gabi asks if for that package X, I always want it from a private source. Is there a way of specifying that?
It was
Yeah.
the one mentioned on the chat as well. Indeed,
Yeah.
this is exactly package source mapping, what I mentioned here. So mapping package to a source, and I showed, you can basically see in the GitHub repo, and I also showed inside NuGet gallery. So this is basically package source mapping. You map packages to sources. So that's why, yeah. So any other questions? Or?
It doesn't seem so. Not on YouTube anyways.
Okay.
People on Zoom, feel free to write in chat or unmute yourself. We're gonna stop the YouTube stream. And we should be off YouTube and on Zoom. So you can unmute